Our planet, as we know it, is changing every single day. Natural resource exploration, agricultural practices, the ever-growing human footprint, even natural disasters like forest fires and hurricanes. These are all examples of how our environment is being damaged and degraded. We are losing critical habitat types and decreasing our global biodiversity. Now, there are two options when we deal with a damaged area. We can leave it, or we can try to fix it. The only way to fix it is through reclamation. Now, reclamation is the process of taking a damaged area and returning it back to a functioning ecosystem. And when we monitor an area like this, the current gold standard is to measure the soil and vegetation properties. But this two-component approach really fails to capture the complexity of an ecosystem, and research has shown that it lacks the sensitivity required to be an effective indicator. Now, more than ever, we need to expand on our monitoring practices. And I have the solution. It's soil invertebrates. They include such things as insects, worms, and mites, and they will lead to more efficient and effective reclamation monitoring. How? They're sensitive. They're sensitive to fertilizer application, to management practices, and in changes in the vegetation. They are also directly linked to an ecosystem's health, stability, resiliency, and their ecosystem recovery timeline. But most importantly, the presence or absence of specific groups of soil invertebrates will actually influence the overall success of a reclamation project. So if we can include them in our monitoring, it makes it possible to alter an ecosystem's trajectory much earlier than if we were only measuring the soil and vegetation properties. Soil invertebrates may be an effective indicator of reclamation success, but they're not currently being used. In my innovative research, I'm identifying the critical groups of soil invertebrates in an undisturbed area and comparing it with an area undergoing reclamation. My research is not only groundbreaking, but I'm breaking literal ground, and it's going to allow me to develop an early detection system. This system can be used by various stakeholders, and it will allow them to identify problem areas. They can implement early course correction, and they can optimize their efforts and resources in their reclamation projects. I will be tearing down the walls that we've built up around traditional reclamation assessment, and my research will lead to more efficient reclamation. It will save money and resources by shortening ecosystem recovery timelines, and ultimately it will prevent these vulnerable ecosystems from failing, leaving us with more successful projects. We owe it not only to ourselves, but to the future generation to take care of this planet, because there's no planet B. Thank you.